Hello friends, today's topic is power required for an accelerated level flight. So we know that power is equal to force times velocity. For a cruise flight, power required may also be written as thrust into velocity. Since engine produces thrust, so power delivered by the engine can be equated to thrust produced by the engine into the velocity at which the aircraft is flying. So we may say that power required is equal to thrust required times velocity of the aircraft. Now from our previous lecture we know that thrust required is equal to W divided by CL by CD. So using this value we can say that power required is equal to W divided by CL by CD times velocity. Now we also know that for an unaccelerated level flight, that is a cruise condition, L is equal to W is equal to half rho V square SCL. We may say that velocity is equal to 2W by rho SCL whole under root. Using this value in this equation, we can say that power required is equal to W divided by CL by CD into 2W by rho SCL. From this we may say that power required is equal to 2W cube by rho S into 1 by CL power 3 by 2 by CD. So knowing that this is a constant value, we may say that power required is proportional to 1 upon CL power 3 by 2 times divided by CD. So we may say that power required is proportional to 1 upon CL 3 by 2 by CD. For minimum power required, we may say that CL 3 by 2 by CD should be maximum. So as in our previous video we saw that for minimum thrust required we must have CL by CD to be maximum. So similarly for minimum power required we must have CL 3 by 2 by CD to be maximum. So this is the condition for minimum power required. Now we also know that from calculus if we equate dPr by dV to be 0 we will get the conditions for minimum power required. Now power required may be written as thrust required into velocity. Now we know that for a cruise flight thrust required is equal to drag, so this may be written as drag times velocity. Now we know that drag is equal to half rho v square s cd, so this may be written as half rho v square s cd times velocity. Hence power half rho v cube s cd. Now we also know that cd is equal to cd naught plus kcl square. So this may be expanded as power required is equal to half rho v cube s cd naught plus kcl square. Now differentiating power required with respect to velocity, we will get dpr by dv is equal to d by dv half rho v cube s cd naught plus kcl square is equal to 0. Now this may be further written as d by dv of half rho v cube s cd naught plus half rho v cube s times kcl square. Now we know that for a steady level flight, L is equal to W is equal to half rho v square SCL. So from here we get CL is equal to 2W by rho v square S. So using this value, we will get 0 is equal to d by dv of half rho v cube S CD naught plus half rho v cube S into k times 2W by rho v square S whole square. Now let this be term 1 and let this be term 2. Now differentiating term 1 we will get 3 by 2 rho v square S CD naught and term 2 will be half rho S k into 4 W square by rho square S square into d by dv of 1 by v. This will be equal to 2W square by rho S into minus 1 by v square. So term 1 is 3 by 2 rho S v square times CD naught and term 2 is minus 2 kW square by rho S v square. So adding 1 and 2 and equating it to 0 we will get 3 by 2 rho S V square CD naught minus 2 kW square by rho V square S is equal to 0. From this we can say that 3 by 2 rho V square S is equal to 2 kW square by rho V square S. Hence we can write it as CD naught is missing here. On solving this we will get CD naught is equal to 1 by 3 2W by rho V square S into whole square into K. Now we know that this term is also equal to CL, so we can write this as CD naught is equal to 1 by 3 KCL square. Now KCL square is also induced drag, so this may also be written as CD naught is equal to 1/3 of CDI. So at minimum power condition, CD naught is equal to 1/3 of CDI or KCL square. So this is a very important result. Using this result, we can say that CD is equal to CD naught plus KCL square. This is equal to 1/3 of KCL square plus KCL square is equal to 4 by 3 of KCL square. And writing CD into form of CD naught, we can write this as CD naught plus 3 CD naught, and this is equal to 4 CD naught. This is equation 1. You can write this as equation 2. And so these are three important results, and this tells us at minimum power, drag due to zero lift is only 1/3 of the induced drag. Now let us try to draw the curve for power required. Now power required is equal to half rho V cube S CD naught plus K CL square, or this is equal to half rho V cube S CD naught plus half rho V cube S into KCL square. Now this can be regarded as zero lift power required, and this can be regarded as power required due to induced drag. Now if I draw a curve of power required, it will be something like this. So this is power required versus velocity curve. Now this will be something like this, quite similar to the curve for thrust required. So from this curve we can see that this point is the point for minimum power required, and this is the velocity is known as V minimum power, and at this velocity angle of attack would be such that CL 3 by 2 by CD would be maximum. So this is the minimum power required point. Now we can also plot minimum thrust required on this. So for that we will have to draw a tangent, and the velocity at this point will be Vmd. At this velocity the aircraft will be flying at an angle of attack such that CL by CD is maximum. So this is minimum drag condition or minimum thrust required, and this is minimum power required or minimum power condition. Now if I draw induced power required and zero lift power, I will get the curves something like this. So this is the curve for power required due to induced drag, and this will be the curve for power required due to zero lift. So from these two curves we can see that at the minimum power condition, power required due to induced drag, that is this point, is more than the power required due to zero lift drag, that is this point. And also from the mathematical result we know that at minimum drag condition CD naught is equal to 1/3 of CDI, or CDI is equal to 3 times of CD naughts. So we can say that power required due to induced drag is 3 times of the power required due to zero lift drag. So this is how the power required curve looks like. In the previous video we saw the thrust required curve, and in this video we saw this power required curve. I hope these things are clear to you. If there is any doubt, please write to me in the comment box and I will try to clear that doubt. Thank you.